In the dim and distant past long, long ago, well, actually the 1980s, software was mostly written in a haphazard way. Programmers had only a few simple ideas about design. Delivery dates, project costs, and software quality were practically meaningless terms. Meanwhile, some clever people started to create notations for designing software. And at some point in the 1990s, the clever people banded together and unified all their various notations. Marketing people loved this because they could sell a silver bullet to kill the nasty beast of runaway software projects. What this industry lacks is engineering rigor, they announced. Just take a look at other industries. They plan up front. They don't tinker about only to discover halfway through that they need to throw it all away and start again. Checkbooks were taken out and large numbers were scribbled and signed by desperate software project owners. And the upfront design tools grew bigger and fatter and contained more and more features. In time, they came with support and training, which raised more money, and so on. But still, the body count of failed software projects continued to rise. The tools didn't really help that much. Instead of fixing the problem, they just slowed down the project. Yes, there were stacks of impressive-looking design documents, but they didn't simplify programming, as had been promised, and they didn't provide the project predictability everyone had hoped for. All of the fine details of the product were still being worked out on the programming shop floor. Confidence broke. Of course, you cannot design a complex software system from the safety of the design room. Programmers rebelled against the heavy, expensive tools and complex methodologies and drew on what they had always seen work well firsthand. Agile methods shook the industry. Risks were slashed because progress was now more visible. Customers knew that they might not get every last whistle and bell, but they would get something useful, the best value for money, before the time and the budget ran dry. The checks stopped rolling in for the UML toolmakers, and most sold out before it was too late. But wait, have we missed something? Have we totally lost design from our software? Have we gone back to the bad old days of haphazard programming? Can't we salvage the good bits from UML and leave out the bad? After all, isn't it good to be able to visualize software, see how it's put together on the inside? And UML could help with that, even though that wasn't its original purpose. UML is still in the minds of the community. Textbooks and articles still use it. We still like diagrams showing how things relate to each other. In the UML jigsaw, one piece shines out as the winner. Programmers like class diagrams. There's a warm reassurance about seeing what owns what depends on what, and what specializes what. So what about if we keep class diagrams and place the rest aside? Let's see if we can get class diagrams working again for the greater good of the software industry. How about we ditch forwards engineering for a start? Programmers don't like it, and it doesn't really save any time. It's easier just to write the code directly in the IDE. So let's just concentrate on reverse engineering. We'll generate the class diagrams from the code. Next, we need to tackle another problem with UML: language neutrality. UML covers only the least common denominator of programming languages. Instead of us trying to ignore the differences, shouldn't we perhaps think what works best for the needs of the poor programmers trying to understand the code? If we want to get all programmers back into pictorial thinking alongside the text of the code, then the picture shouldn't miss out important bits from the programming language. And finally, there's another part of UML which sits at odds with code visualization. UML was designed for hand drawing. That's great if you're still working on paper to do a design up front, but that's not where we're at now. We can drop the hand-drawable constraint and assume we've left paper behind. Let the class diagrams have unfettered interactivity and navigability. We looked at what programmers need and stopped trying to please everyone else. We've picked the dominant programming language, Java. We've picked the best bit of UML, class diagrams. And we've integrated the whole thing tightly into Eclipse. The result we call AgileJ structure views. Agile because that's the main type of project we support. J because we hold loyal to Java. Structure because structure is what class diagrams show. Views because they are reverse engineered only. AgileJ structure views for a deeper understanding of the structure in your source code.